So, today we shall study about p-n junction diode. A p-n junction diode is typically formed by diffusing n-type material into a p-type semiconductor or p-type material into an n-type semiconductor. So, you start with a n-type or a p-type semiconductor as a mother wafer, and then you diffuse the opposite type impurities into it. So, conceptually you can think of as one half of the semiconductor being p type, one half of the semiconductor being n type. It is not like you take one p type bar and one n type bar and put an adhesive and put them together, you are going to get a p-n junction diode. No, it is not possible. You need to have a linear continuum of the semiconductor. So, let us consider a p-n junction diode consisting of p type and n type semiconductors. So, in this p type semiconductor you have abundance of holes in it. In this n type semiconductor you are having abundance of electrons in it. Let us indicate the holes by plus. Actually the materials are neutral, but for the sake of understanding we are representing it as plus minus. Now, when you have a p-n junction diode being formed, in this side you have excess amount of holes, in this side you have excess amount of electrons. So, the holes will diffuse towards the n type side. So, you have holes migrating across the p-n junction to the other side, and now when the holes migrate to the other side, they basically leave behind immobile negative charged acceptor ions. Similarly, electrons they diffuse across the p-n junction to the p type side, and while diffusing they leave behind immobile positive charged acceptor impurity ions. So, if you consider the p-n junction diode, you will find that this diffusion happens in such a way that the total amount of charges migrating from the either side becomes equal to each other. So, if you have in A as the acceptor impurity concentration, per unit volume, and X be the thickness of this region on the p type side, Y be the thickness of the region on the n type side, then you can write X in A W into D, where W is the width and D is the depth of the semiconductor, equal to Y in D W D. So, that means Na X Na equals to Y N D. So, this thickness of the depletion region on either side is inversely proportional to the concentration of the impurity atoms. Now, when this depletion region is formed, so that depletion region is devoid of any mobile charge carriers, but we have immobile ions over there. So, this immobile, so on the n type side you have positively charged immobile ions, on the p type side you have negatively charged immobile ions. So, because there is a charge separation across the depletion region, you have an electric field being set up from the n type side to the p type side in the depletion region of a p-n junction diode. Now, this electric field prevents further migration of charges across the depletion region, and because this electric field exists, there exists a potential drop across the depletion region, which is called the contact potential, indicated by V naught. But now the question comes, if we put a multimeter or a voltmeter across the p-n junction diode, can we be able to measure this contact drop? Can we be able to measure this potential drop across the p-n junction? The answer is no, because this potential is basically balanced by the ohmic drop across the p type or n type side, where you take contacts to form the circuit. The further details are available in the course materials being provided. You are advised to go through.